I think you're all brave for being here because the program was changed a little bit last minute and there wasn't a lot of detail, so I'm happy to see you guys here. Coreboot is a BIOS replacement, an open source BIOS replacement for PCs. So an x86 firmware. And looking at the BIOS, what does the BIOS do? It has two tasks. The BIOS does hardware initialization. First off, it starts up the system so that software can run on it and can use all parts of the system. Then the BIOS goes on to start the operating system. It loads the master boot record, or it reads the master boot record from hard drive. It might start up a bootloader. Maybe you're using Lilo or Grub. Or it can read a CD-ROM or a USB memory stick. And the BIOS also provided interrupt services. That's a software API for applications running in the system to do basic input-output. That's what the acronym is standard for. In reality, no one is using these interrupt services anymore. All the operating systems nowadays, they have their own drivers for every piece of hardware. So the interrupt services have become pretty much obsolete. Only DOS is really using them, and the very early stages of some bootloaders also use them. So we have hardware in it, and we have the operating system starting. Why do we even look at coreboot? What's the purpose of this? Why are we doing this? There's a number of reasons. First of all, it's open source, and none of the traditional PC firmware vendors have open source products. So that's a big deal. Second of all is sort of related to the open source fact. The people who started working on coreboot back in '99, that was the Los Alamos National Laboratory in the US. They were building a supercomputer cluster with a couple of thousand machines. And they really didn't want the keyboard error, press F1 to continue message on their 4,000 machine cluster. So they did the only natural thing, and they started an open source firmware project. Also, I think another reason why coreboot is really relevant is that we see a number of things coming up now lately, the last few years, in the security research field, where there are issues and risks that I'm going to mention a bit later with the firmware. And because we don't really know what's going on there, and we don't have a full insight into this execution stage, there's a lot of stuff that can be going on there, and that's not really so nice. So the BIOS doesn't work really now the way it used to. I mentioned these software interrupts. They really worked as an API. So the operating system and applications would call into the BIOS to do simple I/O, like output characters on the screen or to the serial port, or maybe read from the keyboard or whatever. And this was how the system ran, and it's not really different from an operating system, or not different from today, just that today the operating system has all the drivers and the BIOS isn't really involved at all. So this changed when the first laptop came about. The first PC laptop, it had a lid so you could close it, and when the boss closed the laptop lid, he of course wanted it to shut down automatically. So there came APM. That was the first power management technology used in PCs. When you close the lid, the processor would switch into a new execution mode called system management mode, and do a shutdown, clean shutdown of the system, sort of pause everything that's going on in the system, and then power off, so that you could just close the lid and pack the laptop in your bag. So how many of you guys know about system management mode in here? Okay, maybe 10 out of, say, 80, 90? That's good. It's good. System management mode, as I said, it's a new execution mode introduced in the 386 SL processor. So this is a really old technology, almost 20 years old. When the processor switches into system management mode, it really freezes time. So whatever is happening in the computer is completely stopped, and no changes are allowed. All the state is saved. Once in system management mode, the processor can execute some small functions and really do whatever it wants to, because the normal system is completely stopped. So all state is saved, and a pre-configured system management mode handler is executed. And there was also an electrical signal added to the processor, so a new pin, a new interrupt pin, which is, of course, what was used for signaling that the lid was closed. So when you close the lid, this pin wiggles on the CPU, and the CPU switches, pauses whatever is running, the operating system, switches into system management mode, which will do hibernation, save state to hard drive or to memory, and power off. It's not only this new interrupt signal, though. System management mode can also be invoked by SMI traps. And these SMI traps, they're really a software filter. So you set up a number of rules where accesses to particular RAM locations, so particular addresses in RAM, or particular I/O ports, I/O addresses, will in fact trigger this system management mode. And using this technology, you can quite easily virtualize hardware. Because, for example, the PCI bus runs really completely off of 2 I/O ports, or, well, 8 I/O ports, 8 I/O addresses. And if you hook these I/O addresses to go into system management mode, an operating system trying to scan the PCI bus could, when it reaches a special point, be moved into system management mode, or the system switches into system management mode, and there's a system management mode handler which replies just as if there was actually a PCI card plugged in. But in fact, it's just a virtual PCI card running in system management mode. AMD Geode, the Geode series, which is what we were using in the set-top box, and also something that's been well supported throughout the history of Linux BIOS and coreboot, because AMD really help us out a lot. The Geode platform, it works like a PC, but it's really a new architecture, and it uses system management mode to virtualize PCI devices, like I just described. Also, any PC that you might have that supports USB keyboards and USB storage in the BIOS will be using system management mode, especially for the keyboard emulation. If you're able to plug a USB keyboard in and still type stuff on that to your bootloader, then you can know that your USB BIOS, your USB BIOS is running some system management mode handler. The PS2 keyboard is also using I/O ports. So when the bootloader tries to talk to the PS2 keyboard on these I/O ports, in fact, it triggers system management mode, which will communicate over USB instead, and then return a result just as if there was really a PS2 keyboard. APM was the start, the first try at some kind of power management, power awareness in PCs. After that came ACPI. So ACPI is the advanced configuration and